All right, so we're continuing with chapter 6 on, we talked about cartilage, and then we talked about a little bit about bone tissue, classification of bones, anatomy of a long bone, the periosteum and the endosteum, and we also talked about different kinds of bone cells, which leads us to now the two different types of connective bone tissue, bone connective tissue. And they are compact bone versus spongy bone. So compact bone is what we're looking at here in the top image, histological image here. This is a relatively solid and dense type of bone tissue that's, as we said already, found on the external surfaces of the diaphyses of long bones. It forms the walls of the diaphyses of the long bones, and also the internal and external components or layers of flat bones. And compact bone is arranged in these sort of units called osteons. So we'll take a look at what makes up an osteon. Now, spongy bone is shown here at the bottom, and you can see that the dark pink is the solid bone here with osteoblasts on the outer edge and osteocytes within the interior of the plates. These plates are called trabeculae, and they form this sort of lattice network, labyrinth-style arrangement of bony plates with spaces in between here. Spongy bone, as you remember, is found within the epiphyses of long bones and just interior to the endosteum, located in the diaphyses. So we'll take a look at where we could find all three of those just to demonstrate them. Here's spongy bone again in the middle of two layers of compact bone, and the combination of all three of those layers forms a flat bone. Flat bones are found in the skull bones here, the cranium, such as the parietal bone, the frontal bone, and also the sternum and ribs. So we are talking about those flat bones in this module. So we'll talk about how these flat bones develop as well. Remember that the spongy bone also has the role of hemopoiesis, or blood cell formation. All right, so we're looking at compact bone specifically now in a long bone, but it would be similar to what we'd find in those inner or outer layers of flat bone. And we'll compare it to spongy bone. So you can see compact bone in this region. We can see spongy bone. This region here, rather, the compact bone is in the wall, forms the wall of the diaphysis. Spongy bone forms that inner layer just deep to the endosteum. So we'll compare these two. Compact bone is, we said earlier, has a functional unit called the osteon, and it's these sort of circular arrangement of bone tissue that you can see in this coronal section is running the length of the long bone here. And it's comprised of several layers of bone called concentric lamellae, and then it has an opening in the center called the central canal. The central canal contains blood vessels and nerves that supply the bone. You can see here. So we think of this compact bone as being rigid, but it is vascularized and has nervous tissue penetrating it. As we said, concentric lamellae, we can see over here is this long cylinder of bone tissue that are concentrically arranged, meaning an outer layer, a middle layer, an inner layer, and so forth, several layers, that almost resembling a set of tree rings. And the collagen fibers run sort of obliquely in opposite directions to create more of that rigidity or that tensile strength in bone. Now, if we blow up a single osteon, the surface here, or a slice through an osteon, there's the concentric lamellae, and in between the lamellae we see osteocytes. Remember, the osteoblasts are only found interior to the, or as the cellular layer of the periosteum, but here are the osteocytes, and they are trapped between the concentric lamellae and have these sort of extensions here that allow the osteocytes to transfer information or to communicate between them and the osteoblasts that are found out here within the periosteum. They also help with the diffusion of nutrients and waste between the blood vessels and the rest of the bone tissue. And these processes are found within spaces in the bone tissue, the compact bone, called canaliculi, which is a term that means channels. So the processes are found within these little channels within the that are kind of running through the concentric lamellae. And remember, osteocytes, like chondrocytes, are trapped within their extracellular matrix within a lacuna. So we have lacuna labeled here, but it's hard to designate the space from the cell itself. The cell is within the space of the lacuna. Now there are similar features with spongy bone. We're looking at spongy bone in the endosteum here, or just interior to the endosteum, and it's labeled as the trabeculae of spongy bone. So remember, trabeculae means this labyrinth of spongy bone tissue, and we're blowing that region up here and taking a section of it so that you can look inside a trabecula. So here's the endosteum, which remember has those three different types of cells. Osteoclasts are the only ones here. It looks like they're shown. There's some osteoblasts shown over here too, and osteoprogenitor cells would be in this layer too. But now, instead of concentric lamellae, because we don't have a vessel in the center of it, so it's not called a concentric lamella. They're called parallel lamella or lamellae. And so parallel lamellae are also kind of arranged sort of in layers with osteocytes between the layers, and their process is extending between layers through canaliculi, just like we saw here with compact bone. So we could actually compare spongy bone and compact bone in sort of a table-like fashion, where you can go and sort of check off the list here which of the features are found in compact bone and which of the features are found in spongy bone. And when you're able to kind of come up with your list, then a good way to study is to sort of write some of those multiple answer or multiple choice questions, because you'll have your comparison and contrast information here. So I'll leave you to fill that out. All right, so that brings us to ossification, or the making of bone. So just to explain what we mean here, ossification or osteogenesis is how bone is formed through development and growth. So development, we've got three different sort of stages of life shown here. And development is what we're talking about in this first area here, this first bullet, that begins during the embryonic stage in the 8th week of development and is completed by the 12th week of development. So that's referring to the making of bone, the initial development of bone. That's a developmental period. Then childhood through adolescence, now we're looking at the growth of bone. So bone elongation, growing in the diameter, growth in the diameter of the bone. And then the third stage would be into adulthood, where the bone has fully elongated. Those epiphyseal plates, the epiphyseal plates have finished creating a longer bone and have filled up with bone tissue and is now an epiphyseal line. So what's happening in adulthood here is bone remodeling. So perhaps an increase in the radial growth and any sort of repair involved in adulthood. Now we're going to go back to this first stage here, development. There are two developmental models of ossification, intramembranous ossification and endochondral ossification. Intramembranous ossification is the development of flat bones, so the bones of the cranium, the sternum, the ribs. And although we're talking about sternum and ribs, which are flat bones, in the second module, we're going to save our discussion of intramembranous ossification for module 3 when we do get into bones of the cranium. But just generally speaking, intramembranous ossification begins with a membrane-like mesenchyme of embryonic stem cells that then differentiate into osteoblasts, which will then produce those flat bones, both spongy and the compact layers of flat bone. So we'll come back to that, as I said, in module 3. Endochondral ossification differs in that it's the development of long bones, beginning with a hyaline cartilage model of all the long bones. So the humerus looks like, in the fetus, looks like the humerus, but instead of being made of bone, it's made of hyaline cartilage. The femur looks like a femur, but it's made up of hyaline cartilage. And it's the replacement of that hyaline cartilage into bone tissue that we're looking at here with this type of development. So that's what we'll start with here. These are the different stages, just sort of generally summarized, but we'll add to some details to these stages as we look at the diagrams here in the next figure. All right, so we start again over here on the far left with a hyaline cartilage model. Let's say it's the femur. It looks like a femur, sort of, but it's not made up of bone tissue. It's made up of hyaline cartilage. And what's going to happen is that over the process of endochondral ossification, the cartilage gets replaced by bone. So this happens, this hyaline cartilage model develops between the 8th and 12th week here, where chondroblasts form the hyaline cartilage structure of the that looks like the bone, with chondroblasts sort of ending up in the periphery. Chondrocytes are trapped in lacunae within the interior, and there is a perichondrium that's present. Then in the second stage, what we have here is that the future diaphysis of this model, there we go. The future diaphysis of this model, the chondrocytes begin to hypertrophy. You see that they start to enlarge, and as a result, they're resorbing the surrounding matrix, creating holes in the matrix. And as the cartilage matrix starts to calcify or harden, then the chondrocytes lose their supply of blood and they start to die. And that results in them hypertrophying here. So then, as a result, blood vessels can sort of enter that space, penetrate the perichondrium, which then is going to soon here become the periosteum. And stem cells, the osteoprogenitor cells, essentially, here we go, are going to enter the, we're still in this one here, are going to enter the diaphysis and start to secrete osteoid from inside that periosteum. So the osteoblasts, rather, are going to start to produce osteoid from inside the periosteum, producing what's called a periosteal bone collar around the diaphysis. So you see that sort of building up just in the interior of the periosteum. Then in the third diagram, where the primary ossification center is beginning to form, right here in the middle, what's happening here is that this periosteal bud is penetrating now the periosteum and entering that diaphysis, bringing blood into the interior of the diaphysis, which means that there are osteoblasts entering the center of the diaphysis, and here they start to use that calcified cartilage as a matrix to produce osteoid, start producing osteoid. And remember, osteoid is the extracellular matrix that is produced by osteoblasts. The center where that bone production has begun is referred to as the primary ossification center. So the primary ossification center, very importantly, is in the diaphysis. And all of this is present. This is kind of ending at 12 weeks of development. And from this point, bone development will extend in both directions, proximally, in the proximal direction and in the distal direction. Then in the fourth stage, you see, well, if we go back to the third stage, we see these epiphyseal capillaries are now entering the epiphyses, so that in the fourth stage, we can see secondary ossification centers now forming, and those are the ossification centers in the epiphyses. So same principle here, osteoblasts are brought into the area, start to lay down matrix, bone matrix or osteoid, and that ossification is just radiating out away from the centers, essentially, to completely fill the epiphysis with bone tissue. Other events that are happening here, this is the stage that happens at the time of birth and then beyond, continuing. What else is happening here is that the osteoclasts, the bone resorbing cells, are starting to hollow out the diaphysis to form that medullary cavity. All right, so then we go to the next, here's that same stage we just talked about where the diaphysis is, the medullary cavity is forming. At this stage now, stage 5, all the calcified cartilage has been replaced by bone except at the articular cartilage where we have hyaline cartilage at both ends and the epiphyseal plates, and those are going to, remember, be where bone growth, that second stage, starts to take over. And then in the sixth, last stage in the adult is where the epiphyseal plates have solidified into the epiphyseal line. And you can see there's a lot of blood vessels that are now within here. So we'll continue with bone growth and elongation in the next video clip.